Okay, so now we're going to be talking about finding the domain of a given square root function. Well, we know to find the domain, what we need to set what is under the radical, the radicand, in this case, 3x minus 12, that has to be greater than or equal to 0. Now let me, before I move on, let me explain why. Why does that have to be greater than 0? Because if we get a negative number, we get the square root of a negative number, which is an imaginary. There's nothing wrong with an imaginary number. But the graph will not show up when we graph it. Why? Because the Cartesian plane is created by intersecting a real number line, that keyword is real, a real number line, y-axis, at a 90-degree angle with another real number line, the x-axis, and imaginary numbers don't show up because we're looking at two real number lines. So that's why we don't want imaginary numbers, or we don't want this to be negative. So we set it greater than or equal to 0. When I add 12 to both sides, we end up with this, and we divide by 3, and 12 divided by 3 is 4. Now, let's connect this to the graph. If we get out our calculator and graph this, when we start here at 4, if you plug y equals the square root into your graphing calculator, this is the graph, and we can see the graph exists for x values greater than or equal to 4. Right? It doesn't mean the function isn't really defined when we're less than 4. It is, it's just we get imaginary numbers. Nothing wrong with imaginary numbers. It's just that when we graph on the real Cartesian plane, the graph of imaginary numbers don't show up. Now let's compare this result with this right here. So we, again, don't need to worry about this 5. All we need is what the radicand, whatever is under the square root, that has got to be 0 or positive. Again, when we already solved this, we get the solution as x is greater than or equal to 4. Now again, link this and this to a graph. The graph of this is, we go to 4, but it just moves the graph up 5 places, and we end up with something like this. So the domain, the x value of the graph starts at the same place. It's just that the graph is shifted up 5. So this doesn't affect the domain at all because it's just shifting our graph up and down, and the domain is about x values, not y. And we can see that when we compare the graph of this to the graph of this. It's just shifted up.